Attending. It's really nice for me to speak to this event. And I didn't realize that a lot of the seeds were sown by yourself, Peter. And Steve Bland. What a great story. Okay, so some of my slides and information will be a bit repetitive, but I think compared to what we just heard, I'll try and go into some specifics. Okay, so the compound semiconductor cluster, you got an overview. Woohoo! You got an overview from there we go, from Drew. But I wanted to try answering more specifics of the question: who are we, and how can you access us for the industrial portions? So ICS, CSC, Catapult. On the ICS side, we do devices, design, both design and fabrication, reaching from the research into the prototyping area, and I'll go into a lot more to the specifics of ICS in a couple of slides. Compound Semiconductor, Compound Semiconductor Center focuses on project development and epitaxy, again working in the prototyping regime. Then Catapult can come in post-foundry with systems design, taking from handoff from CSC or ICS into prototyping and finally into system production. Okay, so ICS, what do we do specifically? We work on the device component side. We do design and modeling in-house, fabrication, characterization, device packaging, and device level, component level degradation. And if you were working on a chip of some sort, I used an infrared sensor, for example, because that's what my research group does. We might be able to make this a wafer scale device. We can grow it and fabricate it within ICS. We can turn it into the actual sensor. And I'll show you in a moment that we'll have back-end packaging as well. But only up to the prototype, the one-off. We won't be able to take it into large-scale production. We would need to hand off to somebody to do that. CSC, again, WIN will have a large project development team, and of course the huge epitaxy capability that we just heard about within CSC to carry out larger scale production of these. Again, the reactors that we'll have on campus can do one wafer at a time, and of course CSC can do much more. And then Catapult. They'll take a systems level post foundry. So if we develop an epitaxial method and a fabrication method within the relationship between CSC and ICS, we can work with a foundry here in UK and hand this systems design and everything that Catapult will do in terms of characterization of the system, of the circuit, packaging and qualification specifications of the system itself, as well as life testing. So all the things that a company would need to really validate their product. Okay, so how do you access us? If you're a company, you see these three entities, and we're really working as one under the Compound Semiconductor cluster. But how do you access this team? Well, if you've got specific ideas, and if you know people at ICS or CSC, if you've got specific ideas, you can come directly through ICS. If you've got EPSRC funding for more basic technology, or Innovate UK, we work with companies, and H2O2 often will, from university-led, will start with ideas and then work forward with companies to develop a prototype through these funding schemes. Or if you've got a commercial challenge, for example, you've got a specific problem that you want to, or you've got an idea that you want to progress, you can take that through to Win and his team. And then behind the scenes, it will work somewhat seamlessly that they can put you in contact with the people that you might want to work with at ICS and at Catapult, or directly go to prototyping in this area. Or if you've got a systems level challenge, perhaps you know that you want you want to solve a specific task, but you don't really know how to break it down into components. You just say that you want your or your airplane to fly from Europe to LA much more quickly than it does today. Then CSC can help you, well, Catapult can do the systems design, help you break it down, pass it off to CSC and ICS, and then come out with a life-tested system product. So hopefully that gives you some sense of what the cluster might look like, these three components, how you might work with us. Let's see. Okay, so now I'd like to focus a little bit more on what ICS is. Under one roof, the Institute of Compound Semiconductors is going to, what makes us really unique is that under one roof, we're going to have small area fabrication, 4-inch wafers, for example, and then and I'll show you what our clean room looks like in just a moment. We've got some nice drawing details that I can share with you that shows under one roof, we've got small area production, but operated by the same staff on equipment made by the same company, we can scale up to 8-inch production. So we won't be able to turn out 20 million chips a year, but we can do 100, how many was it? I think 100 wafer starts, anyway, sorry, I forgot the facts. Anyway, our capacity is really quite large, but not foundry size. And our general capabilities are what you would expect for a compound semiconductor large-scale fabrication capability. Of course, it's all industrially relevant with process control and projection mask, EBL, nanoimprint. Then we've got all the metal dielectric deposition tools, ALD, and all the appropriate dry and wet etching techniques. And the idea is that we want to produce under our user facility technology that's translatable at a minimal cost. So we want to be cost effective to help new businesses start. So what are our core competencies at ICS? We'll do integrated photonics and electronics, high-frequency circuit networks, RF, GaN-based, IR photodetectors, and advanced sensors. Quantum photonics and electronics, we've just hired in new professors to work in this area. VCSELs, which is a very important area to IQE, we're going to have a processing and development line along with characterization at ICS specifically to cater to IQE. Power electronics, a number of different types of epitaxy and magnetics. This maps in well with the core competencies of IQE and CSC. VCSELs, as I mentioned, telecom lasers, solar, IR detector imaging, 3.5 on silicon, and GaN-based technology. And it's aligned with what's been recently announced as UK and EU challenges: healthy nation, connected nation, resilient nation, productive nation. We've got applications, of course, in medicine, connected communication, resilient energy harvesting and storage, and then productive nation, making small companies throughout this part of Wales. Okay, so I've got a better overview of what ICS will look like and how it fits into the Innovation Center. This is a mock-up of the Innovation Center. Here you see the existing Kubrick Building. Let's see, no, I'm sorry. This is Kubrick, and this is Hayden Ellis, which is already existing. ICS is going to be right here. The new IC building, the Innovation Center, and our shared facility is right there. So yeah, Hayden Ellis, Kubrick, and the Innovation Campus. Okay, this is an artist rendering of the Kubrick Building. This is Main D Road here, the Kubrick Building. This is a shared space accessed by in the early mornings for delivery to the Kubrick Center. But during the daytime, our parking garages will be out here. People will walk to work or bike to work, enter this shared facility where we'll have high-quality dining and informal auditorium space. More formal meeting space and auditorium space will be in the Spark Center. And this area is very nice because indoors we have a very comfy feeling that mirrors what is outdoors. So people can flow in and out when the weather is nice. Then you enter the ICS building through this corridor. The clean room is glassed or glazed see-through material, so you can look straight into the clean room as you approach the building. You can also view some of the microscopy for the catalysis center through glassed buildings. So our technology is really going to be on display. Okay, and so this, let's see, this is Mandy Road, and this is our, this is the shared facility. Again, you would enter this way. This is the glassed-in corridor, and so this is our clean room. And notice that each floor has capability and structure for green space outside. The architects that we're working with, by the way, have done beautiful spaces all over UK and EU, and they're really lovely to work with because they really care about the people that are working inside of it. Office space on the first floor, and then device and materials characterization on the second floor. Okay, and so again, walking up the corridor, you're leaving this the shared facility. On your right is the glazed clean room facility, so you'll be able to look in and watch people working. And then walk in, you can see this is the jewel of our building. It's an open staircase looking out over this high atrium, and you can see the roundedness of the boardroom that's inside. So what the first floor clean room, or the first floor of the ICS building is, this is just a very general picture. The clean room, the microscopy unit, will have shower space and bike locks in the back. The shower space is important to me because I like to run into work. Then there's going to be meeting space and breakout boardrooms in here. But when you walk in this door, it's very important to us to send the message that this is not campus academic business as usual. We're open for business. We want to do business with IQE and CSC and other companies in the neighborhood that come to work with us. So this ground floor is going to really feel like you're walking into a high-tech commercial site. Our clean room management is going to be seating at the edge of the clean room, of course not inside the clean space, but and notice that there is this garden area. They're going to have lovely lighting, even though they're on ground floor, lovely lighting into the office space. And what's really unique is that we have user offices also outside the clean room. So if you come here, you want to have people on site, that's great. We're going to welcome you. We've got space for you. Okay, and so this is an overview of our clean room. Pardon me, this is very busy, but I'm going to walk you through the what's here. You enter the clean room. Actually, this is where you enter this back-end manufacturing area. So you would actually enter the clean part of the clean room through here and exit into this area. But you would bring your wafers in to start with metrology, move into deposition or photolithography. And again, we've got 4-inch and 8-inch processes side by side, again under the same roof. So you can see that you're going to be able to see what's going on in both parts of the area at the same time. And again, the same staff is going to be writing programs for the basic research and the 8-inch prototyping. And you've got wet and dry etching over here. Microscopy, manufacturing and packaging back here. We also have user space. So if you want to bring in a specific kit for your for whatever process, if you find that we don't have something that you need, you can bring it in, and this area can belong to you. And that's the overview that I have of ICS. And this is, again, the architect's rendering of how they'll light up our area at night. So I thought it would be nice to end with this picture. Thanks a lot.